Okay, so hello once again and welcome to ECON 311, which is microeconomics. For section 6, I'll be taking you through production theory, right? Production theory. And for this section, we'll look at the short-run analysis. And one key thing I would put down for this section is that for production, you need to go back and understand consumer theory. If you do, then production will basically be a walk in the park because the concepts you are using are basically the same. The concept of diminishing marginal utility, a marginal utility, total utility, average, all of them apply in the production theory as well. So understanding consumer theory would do you good to understand production. So in this section, I'll begin a discussion on production, which for the purpose of simplicity, I'll break it down into two time horizons. That is the short run and the long run. So in this section, I'll begin with basic concepts of production theory, including inputs, factors of production, output, technology, production set, production function, technical efficiency, and economic efficiency. So that's basically what I'll be doing for this section. The outline, I have listed them down here. I'll not belabor the point to go through all of them, but once you have the slides, we are looking at production in totality as to definition of key concepts and all that pertains to production. In terms of the learning outcome, we'll define basic concepts in production theory, differentiate between technical and economic efficiency, explain short-run production function, distinguish between total and averages, and discuss the three stages of production, in addition to explaining production elasticity of labor, and then we'll understand the law of diminishing marginal returns as respect to production. The chapter is chapter 29 of varying, which is intermediate micro, and like I always say, any intermediate micro textbook that you find appropriate. So in terms of definitions, because you have also looked at production in level 100, I will not spend too much time going through what inputs are and outputs are, but you know that inputs are what we use to produce goods and services, right? And what are these inputs? They include land, labor, capital, raw materials. All of these are inputs, and outputs are the finished product. The firm imposes a technological constraint on the quantity of output it can produce based on what the input it uses. So based on the input the firm uses and the technology, it can get a given output out of that. So production simply involves the transformation of inputs into output, right? And in terms of the production set, we are looking at all combinations of input and output that comprises a technologically feasible way of production. Right. So what is a production function? It is a mathematical relationship between quantities of inputs and outputs that are used in the production process within a given technology, right? That is the production function. Then economic efficiency is achieved when firms produce at the least possible cost of inputs, right? So a firm can produce, but the question we are asking is this production coming at the least cost? If this is the situation, then we have economic efficiency, and this is also known as allocation efficiency, right? Then technical efficiency is achieved when the firm maximizes its output from a given combination of input. So in terms of this, we have a given production set, right? And the production set, or the shaded area. If a firm is producing A, right, at point A or B, then this firm is not really being technically efficient or productively efficient as well. So producing on the production frontier, which is the production function, C, D where we have Q as a function of labor, right? So here we are assuming that in the short run, labor is the only variable factor of production. So this gives us the optimum, the efficient output that is produced by combining a given set of labor and capital. So this is the production function, which is Q as a function of K and L. So in the short run, I am assuming that capital is fixed and labor is the only variable factor, right? So we change labor to change output. That is the point here. In terms of total product, what is total product? Is defined as the total quantity of products produced in a given period, right? So just like your total utility, the total quantity produced. What then is the average? The average product will be the total divided by what? The quantity of labor that is used to produce it, right? So average product of labor is output per unit of worker, which is Q divided by L. Then when we come to the marginal, we want to look at the addition to total product by an additional worker, the last worker that was employed, right? How much does this worker bring on board in terms of production? So that is a change in Q as a result of a change in labor, right? And that gives us dQ dL, which is the F, where F is a function, the production function with respect to L, dL, and that gives us dQ dL. So when we look at this table, we have the number of workers that are employed, total product. How do we get the average product? The average product I indicated will be the number of total product divided by the number of workers. So when we have 52 products, one person produces it. So average is what? 52. Then in terms of the rest, we'll keep on dividing all of them. Then when we come to the marginal, at 52, we have one person. So marginal productivity of the first person is 52, right? Then total product moves from 52 to 112 when the second person is employed. So how much does the additional person bring on board? It is the difference between 112 and 52, which is 60. So you see that we keep taking the difference in the total product to get the marginal product. And if you can see something here, you can tell that marginal product increases at first and begins to what? Decline, right? Begins to decline. And we'll see this. We'll see that this is our production function that we have plotted, right? Our total product function. And the marginal product is the slope of the total product curve, right? So initially, at very steep levels, you see marginal product increases. Here, marginal product is decreasing, right? Diminishing. So you see that total product is increasing, but it's increasing at a decreasing rate, right? It reaches a peak and begins to fall. When it falls, it means that marginal product is negative. That is why total product is declining. So this also breaks it down by looking at trying to derive the marginal product from the total product curve. So you see that when total product is at the maximum, marginal product is equal to 0. Right? Any further addition to variable input, which is labor, will lead to a decrease in what? A negative marginal product, and that will decrease total products. Okay, so in terms of the relationship between marginal product and total product curves, we'll see that when marginal product is increasing, total product will also be increasing. But marginal product will reach its peak before total product reaches its peak, and total product reaches its maximum when marginal product cuts it from above. Because if you look at it carefully, it is the marginal that is driving what? The total. And when we derive the total by the variable input, we get the average, right? So the marginal will reach its maximum, start to decline before the average reaches its maximum. And when both are declining, the marginal declines faster than the average. So in terms of the stages of production, we see that the first stage is the stage where both marginal product and average products are increasing, right? And then it reaches, marginal products reaches its peak, and average products also reaches its peak. So within this area, we have the first stage of production. And then the second stage is when marginal product is declining and average product is also declining. The third stage is when the total product has reached its maximum and marginal product is at zero, right? It means that marginal product will extend to negative if we increase production, and total product will be declining as well, right? So in terms of production and elasticity of labor labor demand, we see that elasticity is the marginal product of labor divided by the average product of labor. So when we define them, this is what we get. So when marginal product is greater than average product, then it means that labor elasticity, LE, is greater than 1. Right? This implies that a 1% increase in labor will increase output by more than 1%. Right? And the same applies when marginal product is less than average product. Then it means that elasticity is less than 1. Thus, a 1% increase in labor will increase output by less than 1%. So in terms of looking at it, the following numerical values depicts what we are talking about as to the relationship between the elasticity. So we revisit the law of diminishing returns, but this time it is the law of diminishing marginal returns in terms of production, which states that as usage of one variable input increases, its marginal product declines at some point and beyond, right? So in other words, if a firm keeps increasing on adding on labor to the fixed capital, marginal product will begin to decline, reach 0, and even decline further if further additions are continued. So in terms of looking at the marginal derivation, mathematical derivation of the law of diminishing returns, we find the partial derivative of the marginal product of labor with respect to labor, right? And we establish that it is less than 0. That is the second order derivative of the marginal product of labor curve should be equal to 0. So basically, that is about it for our introduction to production in the short run. I have a few questions for you to go through. So show the relationship between the short run total, average, and marginal product curves using tables and graphs. So I started by using tables to show you, use a table and plot a graph. So ensure that same figures are used for the tables as you use the same figures for the graphs to know the points that we are trying to raise in terms of the maximum, marginal, and average product and the total product as well. So in your textbook, find a numerical example and try and derive the graphs and the tables from it. All the best once again, and thank you.